Now we're going to do three-dimensional shapes, and we're going to start with volume. Volume is easier to calculate than surface area. So volume is the amount of space contained inside a three-dimensional object. And today we're going to be talking about prisms and cylinders. A prism is a 3D figure that we name further using the shape of its base. So we will look at rectangular prisms, triangular prisms, and in truth we'll look at cubes, which are square prisms. A cylinder is the same kind of shape, it just has a circle for a base instead of a polygon. The formula for the volume of a prism is the area of its base times its height. For a cylinder, we can make that a specific formula, pi r squared h, because every cylinder has the same formula for the area of its base, pi r squared. Base is a circle. Prism, I can't give you a specific formula because like a rectangular prism would be length times width times height. But a triangular prism would be 1/2 times the base of the triangle times the height of the triangle times the height or depth of the prism. So I can't give you one formula for prism volume. So let's do this. Find the volume of the following shapes. A rectangular prism with length 1, width 4, and height 6 meters. So rectangle is length width, prism is height. That's how I get my formula. Rectangular prism, length times width times height. Here, length is 1, width is 4, height is 6. 1 times 4 is 4, 4 times 6 is 24 meters cubed. Volume is in units cubed. This is a cylinder. So its formula is straight up pi r squared h. The radius of this cylinder is 5. The height of the cylinder is 10. 5 squared is 25. 25 times 10 is 250 pi. And that's 250 pi centimeters cubed, not squared. Let me fix that. Anytime a circle is involved, you should probably plan on giving me 2 answers, like we did in section 4. One with pi, what's written there already, and one where we multiply that. So we do want to do 250 times 3.14, and that's 785 centimeters cubed. Next shape we have is a triangular prism. Triangular prism. The triangle gives us 1/2 base height from its area formula, and the prism gives us a capital H for height of the prism. That's 3 letters, B, lowercase h, and capital H. There are 4 numbers on this diagram. One of them is pointless. It is the 7 centimeters. It doesn't help us at all. So volume is 1/2 times the base of the triangle is 4, the height of the triangle is 6, and the height of the prism, the depth of the prism from triangle to triangle, is 12. All we need to do now is multiply this all together. 1/2 times 4 is 2, so we really have 2 times 6 times 12. 2 times 6 is 12. 12 times 12, 144 cubic centimeters. Okay, a juice box measures 3 by 2 by 4. I want to double the volume by changing one dimension. Which dimension can I change and by what? So let's check the original juice box. And these are rectangular prisms, so this is going to be, these are all rectangle. So volume is length times width times height. So originally we have a 3 by 2 by 4. That's 6 by 4, that's 24. So I want to get 48. And I'm only allowed to change one of these values. So let's say for a second that I keep 2 and 4 the same. What would have to be the first number then? Well, 2 times 4 is 8. So I'm going to take 8 and multiply it by something to get 48. My question mark would need to be 6. What if I kept the 3 and the 4, but wanted to change the 2? It doesn't say I have to change the 3, it says change one of them. So I had to double the 3. Does that work with the 2? Would I have to double it? 3 times 4 is 12. If I want to multiply 12 by something to make 48, it's going to have to be 4. So yes, that works again. And what if I was to do, I kept the 3 and the 2, but swapped out the 4? Does the 4 double up to an 8? Now 3 times 2 is 6. To get 48 with 6, I do indeed have to multiply by 8. So what are we showing here? We can change one value, and if we double it, if we double 1, we double the volume. So doubling one dimension will double the volume. A juice can has a radius of 1.5 inches and a height of 5 inches. Explain what happens to the volume when we double the radius and when we double the height. Okay, so we're going to have to do volume 3 times here. This is a cylinder, so it's pi r squared h. Since we're just comparing volumes, we're only going to do our answers here in terms of pi. It'll make it easier to compare. So we're going to have the original. We're going to have one where we do 2 times the radius. And we will have one where we leave the radius alone and do 2 times the height. So let's calculate this all out. The original juice box is going to be pi times 1.5 squared times 5. 1.5 squared is 2.25. When I multiply that by 5, we get 11.25 pi. When I double the radius, instead of the radius being 1.5, the radius is now 3. The height here will still be 5. So 3 squared is 9. 9 times 5 is 45 pi. And when I leave the radius alone, so the radius will go back to 1.5, but double the height, let's see what happens here. 1.5 squared is still 2.25. 2.25 times 10 is 22.5. And it's 22.5 pi. So what happened to the volumes when we did these? Well, when I doubled the radius, what happened to the volume? What did it multiply by? It didn't double, that's easy to tell. The easiest way to figure out what the multiplier was is take the bigger, the 45, and divide that by 11.25. We can ignore the pi's when we do this. When I doubled the radius, I actually got 4 times the volume. When I doubled the height, I actually only doubled the volume. This is because when I double the radius, you have to remember that we're then going to square that value. And that's what causes the more significant change in messing with the radius versus messing with the volume. Last thing, and lots of empty space here for a reason, is finding the volume of the composite shape. So we've got two shapes here. We have a rectangular prism, which is just length times width times height. And we have a trapezoidal prism. Trapezoid is 1/2 b1 plus b2 height of the prism, or sorry, height of the trapezoid, and the prism gives us height of itself. The rectangular prism is easy. The length, the width, and the height of the rectangular prism are numbers directly attached to it. So literally it's 3 times 5 times 6. 3 times 5 is 15. 15 times 6 is 90. The trapezoidal prism is a bit worse. We need the bases, the height, the depth of the prism is the same. So the bottom of the trapezoid is 5 centimeters. The top base of the trapezoid is 2 centimeters. The height of the trapezoid is 2 centimeters. And the height of the prism, capital H, is 6 centimeters. You can see there's some numbers on this diagram that we didn't use. That's part of the challenge for this second half of the chapter. You're going to have to look at things and say, I don't need you. I'm not using you. Now, the bottom base is 5. The top base is 2. The height of the prism, or the height of the trapezoid is 2. The height of the prism is 6. We do have to do the addition first. That's kind of required. Now let's see, 1/2 times 2 is 1. 1 times 7 is 7. 7 times 6 is 42. The volume of the whole shape, then, is the rectangular part plus the trapezoidal part. 90 plus 42 is 132 centimeters cubed.